Right now, you open a browser window, type a website name, and press enter. In less than 50 milliseconds, one single blink of an eye, a wall of text, video, and imagery appears on your screen. To you, it feels like pure magic floating through the air. You assume your Wi-Fi router simply beams your thoughts up to a satellite somewhere in orbit. And down comes the website. That assumption is entirely wrong. In reality, the moment your finger touches the return key, you trigger one of the most mechanically complex, physically colossal chain reactions in human. Engineering history. Before your brain can even register the click, your request is sliced into microscopic packets, translated through global telephone. Directories, accelerated through glass fibers buried miles deep in shark-infested ocean trenches, and bounced between continents at 99% the speed of light. This is the untold story of what actually happens in those 50 milliseconds. The split-second journey begins right inside your device's memory. Your browser doesn't actually understand words like Google, YouTube, or Netflix. Computers do not navigate by names. They navigate exclusively by numerical coordinates called IP addresses. Your computer first frantically checks its own internal memory. It looks at the browser cache. Have you visited this site in the last few minutes? If not, it checks your operating system's local cache. If neither knows the address, your device sends a miniature electrical signal through your Wi-Fi antenna to your local router. Your router acts as the border control of your house. It wraps your raw query in a protective protocol envelope, slaps your unique private IP tag on it, and shoots it down the copper or fiber line leaving your home, heading straight into your internet service provider's network. Your internet service provider receives the request and sends out a digital detective called a recursive resolver. Think of the recursive resolver as a courier who refuses to return empty-handed until it finds the exact GPS coordinates of the server you want. The resolver begins asking the world's most critical infrastructure, the 13 global root server clusters, distributed across hundreds of high-security bunkers around the planet. These root servers don't know the exact website, but they know who runs the entire .com, .org, or .net neighborhood. The root server points down to the top-level domain server. The TLD server inspects the query and points even further down to the authoritative name. Server, the master ledger managed directly by the website's host. Within just 8 milliseconds, the authoritative server opens the record, pulls out the 32-bit address, like 142.250.190.46, and fires it straight back to your computer. Now, your computer knows where the server lives, but there is a massive obstacle standing in the way: 7,000 miles of open ocean. Most people believe intercontinental data flies through satellite dishes. In truth, satellites handle less than 1% of global internet bandwidth. Over 99% of all global data travels through undersea submarine cables. These are not giant steel tunnels. They are thin, flexible cables, no thicker than a standard garden hose, resting directly on the ocean floor under thousands of pounds of crushing water pressure, tectonic friction, and curious deep-sea sharks. Inside each cable are strands of ultra-pure silica glass, as thin as human hair. The IP address request from your laptop is converted by a laser diode into rapid bursts of photons. These light pulses bounce down the glass core through total internal reflection, crossing the pitch-black Atlantic or Pacific Ocean. At nearly 200,000 kilometers per second, every 50 miles along the ocean floor, specialized optical repeaters splice into the cable, boosting the fading light signals with erbium-doped lasers so they don't dissolve in the dark water. The light pulse emerges from the ocean, hits a coastal landing station, and races down terrestrial fiber lines into a multi-megawatt data center the size of 4 football fields. Here, thousands of liquid-cooled server racks hum in unison. Before a single byte of video or web page is sent back, the server and your computer must perform a cryptographic handshake known as TLS encryption. In fractions of a millisecond, mathematical keys are exchanged, verifying that neither side has been hijacked by a man-in-the-middle attacker. A secure, encrypted tunnel is locked open. The server grabs the requested web page, slices the HTML, styles, and image data into thousands of numbered packets, and fires them in reverse back through. The undersea cables back across the recursive routers, through your home Wi-Fi, and into your machine. Your computer receives the avalanche of packets, arranges them in precise numer, and when you zoom out, the whole journey becomes visible. Your device, the network, the infrastructure, and the systems quietly working together. All of that happens in seconds, while you simply sit there, waiting for a page to appear. If this made the internet feel a little less invisible, subscribe, because there's much more happening behind every click. This is AI.Netminds, where we turn hidden technology into simple visual stories you can actually understand. And the next time a website opens instantly, you'll know just how much happened before you ever saw the screen.